Okay, so today we're going to pick up with the second half of hyperbolas. Originally, when I wrote this section, I wanted to show you how you could graph hyperbolas on your calculator by solving for y. We're not going to do that right now because we simply don't need to for the test. And it was just kind of something fun I want to do. We don't have time for it. So we're going to do problem 3, 3a and 3b. Little typo here. It should be an x, 2x. It says write an equation for hyperbola. And if you need to write an equation, what we need to do is we need to identify, is this going to be an x squared over a squared minus y squared over b squared is equal to 1? Or is it going to be a y squared over a squared minus x squared over b squared equals 1? Why? Okay, so what Holly sees is as she looks at this information right here, if you were to sketch a little graph, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and plot the foci are 5 units up and down, the vertices are 3 units up and down. So if the vertices are there, then the graph goes like so. Very poor drawing of what it actually looks like, but enough to kind of get it in your mind that, hey, this information has a picture attached to it, and we can then say that it's going to be the second equation, because y is positive. Remember, if y is positive, it's up and down. If x is positive, it's side to side. Any questions how we got that part? Okay. Yes. So here, x is positive. Here, x is negative. A, B, C. Do you know what A is in this problem? Three. You know what B is? It is 4. We'll find that out in a little bit. Do you know what C is? 5. So from your information, you know that the focus is located C units away from the vertex. You know that your vertices are located A units away from the center. So we have 3 and 5. What equation do we use to find B? That's our equation that we use. Question. Because vertices, if we look at the previous page, right here, vertices are located at plus or minus A0 or 0 plus or minus A. So as soon as you know anything about the vertices, you can move A units from the center. So C squared is 25. A squared is? We don't know B squared. We subtract. 16 is B squared. So B is 4. Is that enough? Question. Is there any way you traveled in time? Like, is that? Yeah, we did something like this for ellipses. As it possibly did that. Otherwise, I did record this video, but I did it last year. It's possible you could reference last year's. If you sorted it by date, then if you sorted it by date and uploaded most recently, then you wrote down the ellipse information. If you didn't write down ellipse information, then you must have watched the one from the previous year. I can look at what you wrote down and see if it's right. Well, you're following along, so you're seeing it. Okay, so then now we have now we can write the equation. So since we have a squared on the bottom, we have y squared over 9 minus x squared over 16 equals 1. That's my equation for my hyperbola. Question? Going once? Twice? Thrice. We move on. Next problem. We got 3 problems today we're going to do for our notes. Now you have foci at plus or minus 4, 0, and asymptotes of plus or minus 2x. Y equals plus or minus 2x. Oh boy. Okay, those are my foci. So what's the equation going to look like here? Very good. X squared. X squared over a squared minus y squared over b squared is equal to 1. That's what our equation is going to look like. Because the foci are stretched along the x-axis, they are positioned horizontally, so we make x positive. This is difficult, though. Do you know what A is? Do you know what B is? Do you know what C is? 4. C is 4. We know that. Yeah. So as we write this out, hey there, buddy. So if the asymptotes have the equation y equals plus or minus 2x, then you know from the equation of asymptotes y is equal to plus or minus b over a times x. So some people say, well, wouldn't b have to be 2 and a would have to be 1, in order to make 2? Well, not necessarily. Let me show you why. If we draw the kind of, box that we get for our asymptotes up 2 and over 1, down 2 over 1, well, that's the shape we get. And, if you draw your lines through the, corners, you're going to get plus or minus 2x. But couldn't I also get that if I went up 4 and over 2? See how I got 2 different boxes? And those boxes both work for the asymptotes plus or minus 2x. So the question is, do I put my vertices here or do I put them here? Where are they supposed to be? So we know if we take b and divide it by a, we get 2, but we don't know if that's 4 over 2. We don't know if it's 2 over 1. We don't know if it's 3 over 1.5. All we know is if we have 2 times some number and divide it by another number, we get 2. So I know that there's a ratio of 2, but I don't know exactly what those numbers are. And so I set it up x and 2x. Okay? And then we can try to solve for exactly what number that should be. What is an equation I can set up now to solve for those values? What is c squared? A squared? B squared? 4x squared? So I get 16 is equal to 5x squared. Now what? Bye-bye. 5, so 16 over 5 is equal to x squared. We square root, we take the square root of the top and the square root of the bottom. And we get 4 over the root of 5 is equal to x. We don't like the root of 5 in the denominator, but let's not make any more work than what we have to. Okay? Do we actually write a in our final equation, or do we write a squared in our final equation? A squared. So even though a is equal to 4 over the root of 5, when we square it, will the square root go away on the bottom? It sure will. Okay. So you can tell from the work we've done that a is equal to, or x is equal to, 4 over the root of 5. If b is twice that value, what is b going to be? Very good. 8 over the root of 5. Now I can start to write my equation. X squared over a squared. What is a squared? 16 over 5 minus y squared over, what is b squared? 64 over 5 equals 1. Can you leave fractions in the denominator? So this is really quick. 1 over 1 over 16 over 5. We just multiply by the reciprocal. And you get 5x squared over 16 minus 5y squared over 64 is equal to 1. So that's kind of interesting. Have you seen an ellipse before, or a hyperbola before, that has a number in the numerator? We haven't. So therefore, if it asked you to, tell something about it, you couldn't really do it. Not by looking at it right now. You would have to make it look like this. So if you saw 5 over 16, you would have to write it as 16 over 5 in the denominator in order to say something about it. You don't want one like that on the test, do you? What if I attached $1 million? No, still not worth it. Preston be willing to. Preston, what would you buy for $1 million? What would you buy me a timing system for track and field? No? Oh, you only so you can make use of it. I see. All right. Maybe you'd run so fast you'd break. I actually looked at timing systems this weekend. We're gonna purchase one. Not this year, but okay. We got one more example. You're gonna need to take out whatever you're gonna do for homework, or if you have room somewhere on your paper, on your notes, you want to do it on your notes somewhere. That's fine too. But somewhere you need to make room to do one more example. Okay. Somewhere you need to make room for one more example. Okay, so we're going to now do a shifted hyperbola. X plus 1 quantity squared minus y minus 2 quantity squared over 4 equals 1. Once you write it down here. Okay, what's the center going to be? Very good. Center is -1, +2. Any questions how we got that? Okay, direction, up, down, right, left. Why? Because x is positive, this is going to be a horizontal hyperbola. Also, just by looking at the equation, we can identify what a, b, and c are. What is a? 1, because you have x plus 120 squared over 1. Square root of 1 is 1. What is b? 2. And your c value, take 1 plus 4 is 5, square root of 5. All right, let's start to sketch this graph. Okay, so I'm going to start by plotting the center. Center is back 1, up 2. I'll make my box. So I make my box. How many units do I go up? I go up because the 4 is under the y. I go up 2 and down 2. And because 1 is under the x, I go right 1 and I will go left 1. So now I have my box. I can draw my asymptotes through my box. Vertices on the top and bottom, or right and left? Right and left. So you tell me what are the location of my vertices. What's the location of my vertices? Yep, -2, 2. Heard that. And 0, 2. The foci are located how many units in the horizontal direction? The root of 5. We use c in order to locate the vertex or the foci, so we got to move the root of 5 in each direction. So watch what happens here, okay? I start right here at the center. And am I going to move horizontally or vertically? Horizontally. So is the y value going to change at all? No, so the y value in both cases is going to be 2. We know that. The y value doesn't change. But I start at -1 for the x value. And then, how many units do I go to the right? Whatever the square root of 5 is, like 2.2. So I go over 1, 2.2. So what I did is I added the root of 5 onto that. Then I've got -1, and I'm going to subtract off the root of 5, or 2.2. So minus the root of 5. Some people ask, can we write this as -1 plus or minus the root of 5, comma 2? Yes, that'll be fine. Just want to make sure you see that we start at -1 for the x value, and we move there. Any questions how I got the foci? Okay, length of transverse axis. What's the distance between the two vertices? Just 2 units. That's this segment right there. That's the length, okay? And then the asymptotes, well, that's the last part we need to do. What's different about the asymptotes in this problem compared to all the other problems we've done so far? They don't pass through 0, 0. Well, one of them does. So let's write the equation for the asymptotes. We have a y equals, and we're going to have another y equals. Let's work with the slope of the positive line. What is the slope of this one right here? Yep, I went up 2 and over 1. So the positive one has a slope of 2 times x. And what's its y-intercept? Can you tell on your graph? Did you draw a nice enough graph? Yeah, it goes through 4. So what's going to be the slope of the line with the negative slope? Negative 2. Now, what's the y-intercept of the one that goes down? Looks like it goes through 0, so I can just leave it like that. We're done with that problem. You don't have to write this down, but I need to make sure you know this. What if you didn't have a graph? In order to write an equation for a line, you need slope and a point on your line, right? Well, we know the slope for one is 2, and we know the slope for the other one is negative 2. What's the point on the line that both of them pass through? Both of them pass through one specific point. The center, which is negative 1, 2. If you had that information, could you write an equation for a line? Do you remember how to do that? Y is 2, m is 2, x is negative 1 plus b. So you get 2 equals negative 2 plus b. 4 is equal to b. So y equals, my slope is 2, x, my y-intercept is 4. So if you did that for each one, you would still come up with those same things. We just didn't have to go through all the work because our graph was so pretty. This is where the work. Isn't that nice? Okay, here you go. Just got a couple problems for you, not many. Where'd they go? There it is. Okay. I don't give you one where I don't give you a real difficult one for writing the equation like we did in class. These should go hopefully pretty quick. And then I have 2 more on from section 9.4 where you graph a shifted hyperbola. Again, I wanted to sprinkle those throughout. And you've got, about 10 minutes here to ask questions or do a little bit of work. So I'll head on back and start answering some questions.